Okay. All right. Hello, everyone. Welcome to today's installment of the status updates for Corundum. Thanks for tuning in. Let's see here. So, real quick, announcements, product ideas, and then the status updates. So, announcements. Um, unless something changes, the next Corundum developer meeting will be in 2 weeks on December 4th, and the next Switch developer meeting will be in 1 week on November 27th. And I think all of the time changes are behind us at this point, so should be the same time as today. Let's see. So product ideas. I've been putting up this slide. Haven't been any changes to it in the past couple of meetings. If anyone has any questions about any product ideas, want any elaboration, feel free to bring it up in the discussion afterwards. But the idea with this is that if you want to get your feet wet in Corundum, get involved, here's some potential ideas of stuff you could work on. I think if you go back a couple of meetings, I've gone through this in a lot more detail. So if you're interested, you can go watch the recording or ask about it after I go through the status updates. All right, so moving on to the status update summary. The main thing that I've been working on is finishing up the PTP subsystem upgrades and getting all of that merged in and getting all the kinks worked out of that. That's pretty much done at this point. More on that in a bit. I've also been working on a bunch of design consolidation, basically taking similar designs and merging them together to reduce the amount of code in the repository, basically to make my job easier for maintaining stuff, adding new features and whatnot. The fewer files I have to go keep in sync, the better. I also, as part of that, also got a couple of new devices added as well. So I'll talk about that in a bit. There was also a couple of devices that I took a crack at adding, and it turns out those are going to require a lot more work than I was originally thinking. So yeah, we'll see about that. And then just a quick summary of some of the changes that I've made to Corundum, and then moving on to some previous discussion that we've had in terms of port splitting, architectural changes, and the shared development testbed. So let's get into it here. So the PTP subsystem, talked about this in a lot more detail in the past couple of meetings, so I'm going to keep it quick here, but the idea is to distribute time from the hardware clock via a serial link inside of the device, plus a shared PTP reference clock, and then the leaf clocks, which receive this 1-bit serial signal, will take that and basically recreate the PTP clock and then also cross it into a target clock domain. So with this setup, we can route the signal all over the device without using a whole bunch of routing resources and generate the clocks wherever we need it for all the Mac TX and RX clocks and whatnot. And then also what I want to be able to do ultimately, I haven't switched this over yet, but the idea is to support a truncated timestamp format from which the full 96-bit timestamps can be reconstructed. So this will save a lot of FIFO resources and whatnot with handling the captured, received, and transmit timestamps for all the packets. And then they can be converted back to the full time of day timestamps when that's necessary. So for inclusion in the completion records, or internal processing, or whatever. So at this point, the protocol is mostly defined. That's running around on this one-wire link. I also have the hardware clock and the leaf clocks integrated into the design. And the to-do is the timestamp reconstruction from the relative timestamps. So once I have that working, then we can go ahead and update all the designs to use that, which should save some logic resources. But there's potentially some gotchas on that front, so I figured I'll go ahead and get the current thing integrated, make sure everything works good there, and then bring in this newer setup to save some more logic resources once the core parts are working. So that's going to be the next thing that I'm working on the PTP side of things. But the main thing at this point is I have a lot of the module level interfaces and whatnot updated to have the time distribution serial signal added and the old timestamp signals removed or otherwise updated. All right, so that's that. next thing I've been working on is the design consolidation. So, like I said, the idea is to remove redundancy in the code base by merging similar designs. So, previously I merged the Alveo U200, U250, and VCU 1525. But what I realized is that, well, it's actually reasonable to, use the same FPGA core.v file and then have different top level files for boards that are similar but have some, say, clocking idiosyncrasies or whatever. So um, once I made that realization, I'm like, well, hey, I can just merge all of the Alveo boards into a single design, basically, that has a single FPGA core file, and then we can have, I think right now it's like 4 different top level files. So one of them is for the U200, U250, 1525, and I got one of them for the U50, one for the U280, and one for the U55 N and C. And then I guess I put one together as well for the SN1000, but that's not in the repo yet. More details on that in a bit. But yeah, the idea here is, this will share that core file, that core logic across all of these boards to make maintenance a little bit simpler. Then I also use the same idea to merge the a few other designs as well. So the K3P-S and the K35S, also known as the XNIC, X10, and X25. I merged those as well. So obviously you need 2 different top level files because one's ultra scale, the other's ultra scale plus. So there's PCIe differences. But the core logic is similar enough to where that can be shared pretty easily. And then I also merged 2 different designs for bitware boards, the XUP P3R and XUS P3S, which kind of similar to the X10 and X25. They're basically ultra scale and ultra scale plus versions of the same thing. So that worked out pretty well. Obviously, you need different memory controllers and whatnot in that top level file. The other thing I realized is that with the Intel E-Tile designs, that uses AXI Stream to connect to the top level for both 25 gig and 100 gig, versus all the Xilinx ones for 25 gig, that connection is XGMII, because I have a soft Mac in the FPGA core. So for the E-Tile designs, I was able to merge the 25 gig and 100 gig designs as well. So that that simplifies things quite a bit, actually, by removing that extra design that's basically just totally redundant. So that's squared away at this point. Long term, I want to be able to merge, basically do the same thing with the Xilinx devices and merge the 25 gig and 100 gig designs. Basically, once I have a new set of GT plus Mac wrappers that include both the CMac as well as the 25 gig Macs, then I should be able to pull the trigger on that and get everything all merged. You'll still be able to build, a 25 gig design that doesn't have any 100 gig stuff in it, or a 100 gig design that doesn't have any 25 gig stuff in it, just based on module parameters, if you want to, with this new wrapper. But it's just more of a question of, where's everything going to sit? So yeah, we'll circle back around to that once I get a more flexible transceiver wrapper that integrates the CMac operational. But there's a few things in there that I need to figure out. Let's see. I also added support for a couple new devices while I was working on some of this, some of these modifications to the code base. So I have the Alveo U55N/Varium C1100 support finished off and added in. So that's going to be available. Well, it's currently available in my development repo. That'll make its way into the main repo this week. I also added support for the Bitware IA420F. They sent me one of those cards a couple of months ago, so I'm like, all right, I should get that off of my plate and get that added. So that's squared away. Still on the to-do list, the U55C is actually pin compatible with the U55N. So really all you need to do is change the device name and the placement constraints, and I think a couple of other minor things in terms of like the HBM size is different on the U55C. So I think I've done everything necessary for that, but I don't actually have a card to test with, so that's going to remain just sitting around on my machine until I get my hands on a U55C, at which point I can add it upstream to the repo. So I don't want to put it in there if I haven't tested it yet. I think it'll work. It builds, it closes timing, but I don't have a card to test it on yet. I also took a crack at getting the SN1000/AU45N card working. The first problem I had to sort out with that one is the JTAG. I was thinking about laying out a board or something, but I had the connectors, and I'm like, yeah, I just want to get this done. So I, air wired something with some of the fine blue wire and some epoxy to get a JTAG connector to stay put. If you're interested in what that looks like, I posted a picture of it on the Zulip, but it worked. I was able to talk to the card. I put together a design on there that ran, but then I realized that the card uses a VCC into 0.72 volts. So in Vivado, I don't know if you've looked at this in the drop down for all the parts you can pick. They got all the different speed grades. You might notice there's a -2, a -2L, and a -2LV. But if you look at the data sheets, there's only a -2 and a -2L. There is no -2LV. So what is that? Well, the difference between the -2L and the -2LV is VCC int. -2L is the 2L speed grade with a VCC into 0.85. The -2LV is the -2L with VCC into 0.72. So all I had to do was change the part, and then it failed timing miserably. So that I'm going to have to come back to later, once I've made some other timing optimizations. So when that closes timing, I'll go ahead and add that to the repository, but that's going to be slightly more complex, I think, before that one will be supportable. Right, and then the last thing that I was taking a look at is the N6000 card from Intel. Well, I guess I don't have the one from Intel. I've got the N6010 card from Silicom, but ostensibly they are the same and can run the same firmware. But Intel has this highly complicated hardware root of trust thing that I don't want to deal with, because you have it's not so much just about having to jump through a bunch of hoops, but you have to do some sort of you have to do a bunch of key management stuff, and you have to do some sort of irreversible provisioning on the card, which presumably involves like blowing eFuse. I don't want to do that on a multi-$1,000 FPGA board. I would rather just disable the hardware root of trust and just load stuff on the FPGA directly. But I haven't even been able to figure out how to get JTAG access to the FPGA on this thing. It's got a JTAG header, but if you plug into that, you only see the max 10 FPGA. There's some dip switches. I tried various combinations. Some of them definitely seem to affect the JTAG chain, but haven't been able to figure out how to talk directly to the Agilex FPGA on there. So I'm going to have to talk to the Silicom guys and see if they have instructions for how do you disable the hardware root of trust and just use this thing as a normal FPGA board. So yeah, once I figure that out, then this should be pretty straightforward to support, because all the Agilex parts are basically the same. You got the P tile for PCIe, the E tile for Ethernet, and maybe a couple of clock connections and a couple of LEDs, and that's it. So should be simple to port once I figure out how to get stuff running on the FPGA. So that's, I think, everything in terms of new device support for the moment. All right, so it's a real quick summary of the updates that I've made to the development repository recently. I got the new PTP time distribution components integrated. I've merged a bunch of designs, which I just talked about. I also made some modifications to the firmware update code to handle shared JTAG IDs, because there's a bunch of boards that that seem to have multiple devices using the same JTAG ID. So the U280, U55C use the same ID, U50, U55N use the same ID. So had to make a couple modifications for those checks to work correctly. I also added some warnings if the application bar didn't enumerate properly. I know somebody was asking about that. I was running into some issues with, why can't I talk to the application section? The app ID is there, but the bar isn't there. Well, sometimes you have to reboot depending. And I did take a look at how Linux handles the bars, and I couldn't figure out if there was an obvious way to tell if a bar was present but hadn't been assigned memory. It basically, as far as I could tell, it seemed like from the standpoint of the state in the PCIe device structures, it looks the same as the bar is just totally non-existent. So it's a little bit of a side note. There's a bit for an unassigned that basically to indicate that a bar or a resource is not assigned. It seems like that should be set, but it isn't set. So don't know. What I ended up doing is basically checking to see if the application register block is present that has an application ID in it. If we see that, but we don't see the application bar, then I just print out a warning saying, "Uh-oh, something's weird with the application section." And then it's up to the application logic. You know, if you have a little user space tool or a kernel module to, you know, detect that, oh, that the application section is not present, and, you know, and raise an error there if you're actually trying to perform some operation. So anyway, that's now in my development repository. So if anybody's messing around at the application section and it's you're having problems with the bar getting enumerated, well, you'll now have a hopefully helpful error message. I also made some adjustments to the Alveo designs to source the 125 megahertz clock from one of the memory interface clocks instead of the GT clock. And hopefully this will improve the PDP time sync performance a little bit, especially when we start looking at using the SI570 chip on there for, you know, White Rabbit, basically. So that was a relatively straightforward change, although first time around I screwed it up and also removed some of the clock init stuff on the Alveo U200, and then that caused the thing to not come out of reset properly, so I had to revert that, but that should be working now. And then again, I also added support for a couple of new devices, the AU55N and the IA420F. All right, so that's about it for all of those, just a summary of the updates. Now, getting on to some of the other changes that I'm working on / mulling over. One of these is port splitting. So ideally, what we want to be able to do in Corundum is take a 100 gig port and split it into 4 25 gig, or, well, not necessarily 25 gig, but just separate ports, which could run at 25 gig or they could run at other speeds. And part of this is to figure out the clocking side of this, and I did some tests with the RX clocking. So the first thing I did is I switched all the 100 gig designs to use RX recovered clock instead of using the TX clock. So that's done, and all of the designs in the development repo have been updated along those lines. And on the RX side, I tested using separate GTY RX clocks. It works, but I'm holding off on that because I think what I want to do is when I put together a new wrapper, then depending on whether you're using, you know, 100 gig port or have the option of port splitting, we can switch around the clocking infrastructure as necessary. So if you're just doing 100 gig, you don't need to use separate RX clocks. Then you can save a few clock routing resources if you go that route. And then on the TX side, the situation is slightly more complicated because basically the CMAC, it assumes everything's running in the same TX clock domain. And if we're going to be able to run the 4 channels separately to run them at various combinations of link rates, then we have to have a way of handling that. I'm not sure the best way of going about this. So the BuffG GT only has 1 input, so you can't really switch, unlike the BuffG Mux where you can potentially switch. So I'm not sure if trying to do something with switching is even going to be feasible, or if it makes more sense just to say we're going to kind of depart from how the CMAC is set up and instead insert some very simple phase compensation FIFOs to get data from the output of the CMAC to the other 3 channels. Obviously, it'll run in the same clock domain as the first channel, but the other 3, yeah, you might need to jump through some hoops for that. So that's kind of what things are looking like at this point for clocking. Once I start putting together the updated transceiver wrapper, these should start to become a little bit more clear. The other component to this is how to handle the actual data. And part of this is, okay, if we're going to make a Mac wrapper, what is the interface going to look like? The other part of this is how are we going to pass that interface through the Corundum hierarchy? And I can think of at least 4 different options for doing this with some various advantages and disadvantages. We could either have a single streaming interface that interleaves everything. And for that, we're probably going to have to interleave multiple frames. I don't think we're going to be able to send, 1 frame at a time in order for that to work. We might be able to do a concatenated interface. I think this one I think is kind of what the MR Mac does. I think it might only make sense for coming out of hard logic. I don't think it necessarily makes sense to try to do something along these lines for soft logic, because you might have to do clock switching and weird stuff like that, which I think could get really messy. So that's probably not going to make sense. Well, unless it's synchronous. But even then, I'm not sure it's worth the trouble. Option 3 is to have a single 100 gig interfaces and then separate interfaces for the separate lanes. Downside about this is you now need basically 2 different sets of streaming interfaces, which uses a lot of logic resources. And then the last option is to do channel interfaces, which is basically the same, except the first 25 gig interface would be shared with the 100 gig interface. Basically, you have a lane 0 interface, which is either 100 gigs or lane 0, 25 gig, and then 3 additional interfaces, which get turned on when you split the ports, basically. So a little bit better in the logic resources standpoint. Still need multiple streaming interfaces. It's not a nice power of 2 because it's 3 instead of 4. And there could, I guess, maybe be some clocking concerns between the 100 gig interface and that first 25 gig interface. Not sure about that. So I think some of this will probably become a little bit more clear once I actually start, working on the updated wrapper and actually trying to put some of these pieces together and to just see how things are going to work. Another potential consideration here is frame preemption. There's some talk about, supporting frame preemption on the Macs for not TDMA, but
or TSN.
TSN, yeah. I think it's some starting with T. Yes, it's for TSN that is necessary for some of those. So the question is, okay, if we're doing frame preemption, the way the Xilinx Mac does that in their 25 gig Ethernet subsystems, they have 2 different streaming interfaces, one for the express traffic and one for the preemptible traffic. Well, does that mean we have to double the number of streaming interfaces here? Or is there a way, like if we did a single streaming interface where everything is interleaved, maybe there's a way we could do preemption that way? Not sure. That would save some logic resources if we can use 1 interface, but that does open up a whole can of worms in terms of whatever is doing the interleaving has to be aware of basically what the Mac is doing in terms of preempting frames, because you can't preempt a frame anywhere. You got to preempt it at certain points. So, yeah.
I guess the IEEE description is more aiming at having 2 distinct interfaces. That's how they describe it, at least.
Well, right, but I'm more like, okay, we can certainly do that. I mean, that would not be hard, but it's more in terms of, is there a way we can save on the logic resources and buffering a little bit by, putting these in the same buffer and following the same paths? But
yeah, of course,
may just end up opening up too big of a can of worms to be worth it. Also, just as a side note, do you know exactly what kind of restrictions there are on where the frame can be split? Because if you can split it anywhere, then that kind of makes things annoying when you're operating at 10 gig or 25 gig with your 64-bit wide interfaces, versus if you can only split on 8-byte boundaries. It seems like you could split it anywhere.
Yeah, that might be possible. So there is a minimum and maximum length, obviously.
Yeah, you can't split too close to one end of the packet.
Exactly.
Because you got to make sure that every piece is at least 64 bytes.
So on the transmit side, I guess you can, if the implementation has some limitations on granularity, that might be acceptable on transmit, but on receive side, I guess you need to support any boundary between the minimum and maximum. But I'm not sure. So the last time I read the standard is like years ago.
Right, right. Yeah, that was kind of my read as well. So, okay, that's annoying, but it is what it is. Yeah, so that'll be something to look at as well, is making modifications to the current 25 gig max that I have to support frame preemption. I guess another component as well is that it might make sense to use different configurations of interfaces at different points. So for example, the Mac wrapper and Mac modules probably makes sense to use something more like option 3, where we have everything all split. And also for frame preemption, probably split interfaces. But when we're moving up to, once we go through all of the FIFOs and Corundum and whatnot, well, maybe it makes sense to merge some of this stuff together and maybe present something more like option 1 at the interface level, when you have the single synchronous interface that carries all the data. That might make sense. I'm not sure. I guess we can play around with this as stuff starts to come together. Right. So that's that. And then the other thing that I've been mulling over is moving towards using a single hardware interface, basically where we remove all of the duplicate descriptor and completion handling logic and whatnot that's currently associated with the quote-unquote interface, the mqnec interface.v file. And instead of having multiple of those, we just have one. And then software can split things accordingly and manage the resources. And I think this is going to be better from a scalability standpoint, and also on some of the smaller FPGA boards. I guess there is potentially a question of things like packet rate and whatnot, if we have more sharing, what that might do. So, and also with the embedded switch, where you don't necessarily have a whole bunch of ports that are directly connected to the interface. Instead, you have an E switch and then a bunch of stuff on the other side of that. It's probably going to make a lot more sense to think about, kind of reworking how that connection is made and how the resources are managed and whatnot. So this is something that I'm starting to think about in terms of what the data path is going to look like, and how some of the buffering is done and whatnot to support having a single interface on the hardware side. And I guess also I've been starting to look at resurrecting some of the upgraded descriptor management and completion management code that I had a while ago. And as part of that, that's going to use more logic resources. So if we just have one copy of that, that's going to be that's probably going to be a good thing. I'll probably keep the option of, if you do want multiple hardware interfaces, you'd be able to configure that via module parameters and whatnot. But it's more like by default, we'll flip all the designs to having a single hardware interface, and then the software will deal with presenting that as multiple interfaces at the operating system level. Right, so that's that. And then also the switch integration, as Carlos has been working on putting together the packet switch design. So if we're going to integrate that into Corundum on some level, there are some questions in terms of how that's going to be exposed at the application section interface level and with the internal switch ports and whatnot. So, and there's also a clocking consideration there. It might make sense to decouple Corundum from the PCIe clocks so we can run it synchronous with the switch clock. And that could potentially provide some benefits where you can run Corundum a little bit faster. Maybe that'll improve the packet rate a little bit, and run it synchronous with the switch to avoid some internal clock domain crossing. Not 100% sure at this point about all of the pros and cons, but this is also something that I've been putting a little bit of thought into, that might require a little bit of additional consideration. All right. So I think that's most of the architectural stuff. The application section pass through it's something that the folks at Emily have been working on. I guess once I get all the changes that I've been working on over the past couple of weeks pushed up to the main repository, then I think you guys can rebase your updated application section pass-through code on top of that, and then we can get that merged in. So hopefully later this week we'll be able to take a crack at that. Yeah, all that merging took a lot longer than expected, but it's looking pretty good now. So within the next couple of days, I think I'll be able to have that pushed up. I want to run some more tests to make sure I haven't broken anything else. So,
That makes sense. So I guess we're almost ready to rebase for whatever whenever you are ready. I get also.
Right. Yeah. I mean, you can certainly take a look now with the code that's on the sysnet repo, because that's going to be what gets pushed up to the mainline one. I mean, it shouldn't be all that different from what's up there now in terms of what's going to affect the application section pass through, but yeah.
Yeah, makes sense.
But yeah, I guess this slide's a little bit out of date because they've come up with a pretty good technique for using macros for doing this. That involves just including, you know, one file and not a whole bunch. So yeah, it should be a pretty nice setup once we get that merged in, which should be pretty soon. All right, let's see. And then the other thing that I've been chipping away at is the potential shared development test bed. So I got a couple different optical switches. I've got a couple of host computers. We can put together whatever assemblage of FPGA boards we want. Got a couple different 100 gig packet switches. You know, it should be a pretty nice setup. Oh, I also have the Arista 7130 LB FPGA based switch as well that I could hook up. So yeah, I guess the main thing to figure out for the testbed is how to manage things on the software side. And I know we had a discussion on LabGrid before. There's been some discussion on, you know, some of the more, you know, DevOps solutions like Ansible and whatnot. I'm not sure necessarily what the best route is going to be, but what I'm thinking is going to be the most flexible solution is to do some sort of stateless, diskless, net booted setup. And then if we want to use LabGrid, well, we can just have a LabGrid image we can boot up on top of that. Or if we want to do VMs, we can boot up an image with KVM or QEMU or VMware or whatever on top of that. So I think that's definitely a and then that would mean we can run whatever setup that we want, as well as having, you know, direct hardware access. Because I think while the LabGrid and VM solutions, they do sound really nice for certain applications, I think for the test setup that that I have here and some of the stuff that I've been doing, there's nothing that really beats just a direct booting directly on the host and directly talking to the cards. Because there's definitely, even if you have VMs, there's an issue of, okay, what happens if you reprogram the FPGA and you need to reboot the machine to reconfigure the card? Well, now you gotta, that affects everybody using the machine. So I don't know, some stuff is not super clean if you're going with VMs in a hardware test bed. So, but I don't think we have necessarily a an off-the-shelf solution that I'm aware of that could work for that application. I have been taking a look at kind of the supercomputing space because they seem to have a lot more, you know, diskless management setups. But one thing that I've noticed is that a lot of those, it seems to be, hey, we have one image that we're going to boot on all of the nodes, which, okay, I mean, that makes sense for a supercomputer, but it would be nice if we could have a nice way of, you know, booting different images on different machines. So not sure if anyone has any ideas on that front or wants to put any cycles into getting stuff figured out. But I think if we can come up with a either locate a decent setup, or if we have to do some work to piece something together, they could potentially be used, you know, in other test beds as well. So, you know, either MLE or other universities that might be doing similar hardware development work.
Yeah, maybe just to clarify, so LabGrid is nothing that is booted. It's just infrastructure to connect to hardware. So we don't boot anything with LabGrid. We just use it to arrange hardware and access nodes. Might be a hardware FPGA board or a Raspberry Pi or a VM or a workstation or whatever. That's more a management tool.
Right.
So it's like orthogonal to VMs, kind of. It doesn't actually run anything directly, or it must not run directly on the node. It's
Okay.
just
So you're
means
doing
to access
everything
it.
via SSH or whatever.
For example, but SSH is kind of orchestrated by LabGrid as well. So
Right.
maybe I can just okay, no, I can't share anything.
You want to share something? Yeah, sure. Let's we'll do that. One moment. I'm gonna push
Yeah,
a button here. Oh, I didn't want to do that. Come on, Zoom.
the other one.
Well, the little pop down menu button is tiny compared to the actual button for sharing stuff. So I went to click the little drop down button and click the share button because it's like, yeah. Anyway, you should be able to share now.
Yeah, I can, I guess. So now I can't see anymore what I share. No, I can. Okay. I guess it should be just seeing like an overview about how a LabGrid setup may look like. So there is clients on the left side, and there is a coordinator in the middle, and there are exporters on the right side. In our setups, the client is anybody being logged in on a PC that operates portions of our setups. It's a command line tool also called LabGrid client, and the coordinator has knowledge about the available resources being exported by the exporter, and the actual hardware is on the furthest right, which are devices that are accessible by services provided by the exporter nodes. So, for example, if you have a UART here on the top left of the nodes, of this hardware nodes, it's connected to one of the exporters, and it's assigned to a so-called place. And then a client can reserve or acquire this place and then operate this UART, and that's then tunneled via, I don't know what the actual tool is, but by the regular Linux UART over TCP tool. So it's just about providing a grouping resources, making it available, reserving it, like coordinating access, and that's what we use to download bit streams onto FPGAs, how we switch on and off power. That's kind of the architecture of the tool, but it's not about running something somewhere. So that's a second layer, let's say.
Well, so these exporters here, where you're exporting the serial port access, how does that work? Does the coordinator run a program on the exporter machine via SSH, which opens up that port or something, or how's that managed?
The exporter is a service running on this exporter node that's connected to the coordinator and publishes available resources.
Okay.
And
Okay.
a client asks the
you are running
coordinator.
software on the exporter nodes that you're going to be connecting to.
Yes, but the exporter node is not necessarily a node where the FPGA is kind of socketed into. So it could be something adjacent to it. For example, if you have an embedded boards, there is no kind of tight connection between the exporter and the FPGA. So it could be any PC sitting besides it, for example, which might make sense in case you program a bitstream and you have to reboot, and then your exporter is gone, right? Maybe that's not so nice. So usually we have little nodes sitting adjacent to the actual workstations and PCI Express hosts for FPGA boards, and that just operate setups. In our case, it's usually a couple of boards, and they are not they're not really part of the test setup. They are controlling it.
That's an interesting setup. So basically you have kind of two sets of computers. One set are the computers that actually have the FPGAs installed. And then you have another set that are just basically managing those.
Yeah, let me pull out you remember the FOSDEM presentation we did together.
Right, yeah, briefly. I was probably more
Yeah,
focused on my part than
obviously.
I don't remember all of the details that you talked about, but yeah.
No, there was a picture of our setup, and I just quickly pull it out, and maybe I can show something. Maybe it's too small and we don't see anything. I'm not sure. There it is. Now we can't see it, I guess. No,
I
we
guess
can't see
you had
it.
a picture of the machines in your lab that
Yes.
have that shows the setup
Yeah.
with the multiple the smaller management machines.
Yeah, but you can see these small machines. So usually we just have like old laptops sitting around, because then it's also easy to hardware have hardware access to them. You're running into the lab, and then you can just type on the exporter node. That is interesting every now and then. But yeah, it's not necessary. So for larger setups where there is nothing to interactively do with it, we have other nodes as well running exporters. Yeah. But that's the general idea, right? And we added some capabilities to upstream LabGrid, although we are running a pretty old version, I guess. So we have changed JTAG support for getting the ability to interactively talk to the FPGA via JTAG. So the original support was more program a bitstream into the flash, reboot. That's okay. But yeah, we want to have access also live to have capabilities to run ILA captures and so on, right? So
So does
that's
that like
something
start
we
up the
added.
Vivado hardware server or something, or?
Yes. So actually, it's like how would I put it? So your session, if you're starting to run, if you want to use a portion on the right side here, you're having your client and you're acquiring a place, and a place is a group resource set. It could be distributed across a couple of exporters, but usually it's one exporter node that exposes a couple of resources as grouped into a place. So you're running your client, saying labgrid-client-p place name acquire, and then it's your place. Nobody else can actually use it via labgrid, which is the first interesting thing. We run CI in parallel on these setups, and now the CI is not capable anymore to do some runs on it, right? Because I reserved it. And once you run this acquire process on the exporter, the hardware server gets started automatically. So and we have some means, at least for us, scripted into that we can also run different versions of hardware server. So it's not the global hardware server, but it's something.
Yeah, because I've had issues where you got to match the Vivado version. So if you're depending on what version you're running, you got to run the same hardware server version. And then I guess Intel also has their JTAG-D, which is similar idea in terms of
Yeah, we made this work as well. So now currently we are able to run similar things for Intel and Xilinx services. We are still working on microchip support, and we haven't looked at Lattice yet. But I guess for you that's not a problem.
Yeah. Right. Yeah.
Yeah. So that's kind of the system we use. And maybe there is there's a lot of more stuff. So this is a presentation here at, I guess, Embedded Linux conference, I think, where these guys here, the Pengutronics guys that develop a lot of portions of LabGrid, presented what they did.
Interesting logo they got there. That's a penguin Pinocchio.
Yes.
I try to trust those guys.
Yeah, right. Yeah, and I guess that these setups, or as I show here, that's more like the target they are aiming for. So it's embedded devices
Oh, that has
running
one of
some
those,
sort of embedded operating systems.
was that a micro SD mux sort of thing? So you can talk to it via USB if you want. Is that
Yeah, that's the thing here in the back. Yeah.
I think you mentioned that you use those at some point.
Yes, we do. That's the old version you're seeing here. And the newer version is like a little bit strangely layouted, but works pretty good. Yeah. Every now and then we use these.
That between USB and connected to the target device. Is there, you have to use a special piece of software for that, mount, unmount. If it's unmounted, then it's hooked up. If it's mounted, then you're talking to the card. Or
Yes, but it's also integrated into LabGrid. So you can kind of say LabGrid
okay.
host version or host mode, and then LabGrid dot mode, and then it switches on and off. And you can also use the LabGrid download command to kind of transfer data here into this. So that's also integrated kind of. And there is also hooks of LabGrid into upper layers going into Python for PyTest, for example, so that you can in what is it, in the session scope, you can kind of put your bring up portions like switching on boards, waiting it for booting it into a special mode. Let's say like you're waiting until Linux has been booted, and then you can actually execute tests, for example. Yeah, so that's why they build it, right? And then we do some more stuff to trying to control like physical machines while we are kind of operating IPMI based on power on off commands of LabGrid. We are currently working on integrating the same thing for virtual machines. Like we're trying to, we're aiming at building a bridge that crosses the boundary to kind of talk to Virch or libvirtd on the virtualization host, and then kicking off virtual machines then as needed. Yeah.
Right. So I guess it's one thing just to be able to start up and shut down virtual machines and switch images and whatnot, but I guess you might also need to manage, PCIe resources or something if you're doing PCIe pass through, just to complicate things.
Yeah. So what we do now is, or currently is, we kind of have at max for now 2 different PCI Express devices in a machine that we want to pass through. And usually we have one VM for one and another VM for the other one. So it's simple for us. If it's more complicated, I guess Joachim is here. I guess you have to put some more magic in the QEMU management code to actually being able to share this more dynamically. Not sure how this actually would work.
Yeah, I mean, probably the simplest thing to do is to have one VM per PCIe slot, basically, right? So if you have, 3 or 4 devices, then you spin up 3 or 4 VMs, one per device, to make it, more flexible than that. I think would potentially open up
that's what Uli meant. That's what we are doing.
Right.
Yeah. So if it's completely dynamic, I mean, yeah, I guess you have to write the proper support into LabGrid or helper module at least, and perhaps manage separately the resources, perhaps the virtual machines, and combine them with a separate resource which is managing a given slot.
But isn't it actually also part of the QEMU configuration which slot you pass through? So which PCI Express socket is passed through?
Right. Yeah, exactly. And so LabGrid would have to modify the VM description. So in case of libvirch, you would modify the XML before you start the machine.
Oh, so that's
And
wait, so where does that live? That's associated with the actual virtual machine itself, not the host. Like the virtual machine image says I want PCIe ID whatever.
Well, a virtual machine description, as far as libvirt is concerned,
Mhm.
is just a description of the hardware which shall be emulated in quotes. And adding to that, there's a piece of information which tells Qemu to pass through a certain PCIe function.
Right. Okay.
So that's all part of the description of a virtual machine, and according to that description, libvirt is then just putting together a Qemu command line basically, and starting it and connecting to the Qemu monitor to control it.
Yeah, I mean that almost seems like just a limitation of QEMU in terms of how that description is put together, because it almost seems like what would make more sense is to have like slots that are defined. Then you could say I want to run this image on this slot, but instead you have to take your virtual machine image with its associated XML file, edit the XML file, and then run that. So yeah, I guess that does complicate things a little bit. Because usually you don't need to think about that with virtual machines. You just however many you want, you just run them. So when you're connecting the VM to the hardware, that things get complicated.
Yeah, if you don't want to modify the XML file, you could just have all the combinations and pick the right combination. Because I mean, one XML file can basically reference, or multiple XML files can reference the same disk image, for example. So that's all possible, but well, you then have to manage that not two VMs are started pointing to the same
or maybe you turn it around and then you don't have the XML file at all. You just write it out based on some other information on the fly when you want to boot the VM.
Well, yes,
maybe you could just
from scratch.
Yeah, but on the other hand, libvirt is offering a lot of convenience features. So I don't know if it really simplifies things if you start Qemu directly. I don't know. It depends.
Maybe you could.
I'd say. But what I wanted to say is modifying the XML is not a big problem. I mean, this would be under the control of LabGrid. So it's not like anybody is opening an editor and editing the XML file. This would be done by LabGrid. So, and editing the XML file from command line should be possible too. At least I've seen how they do it. I've never used it myself. But I don't think there's a problem in that particular thing of editing the XML.
Maybe you can just do it via a libvirt command. So is this possible to just dynamically do this, like without actually editing XML?
No, I really think you have to edit the machine description, the domain description it's called. You have to edit. I don't. Well, okay, I'm not 100% sure. It might be possible to say, do a change which is non-persistent. So, like when you add a disk. So if you configure the virtual machine for virt.io for disk access, you can basically add more disk devices at runtime, and there you say at runtime, I want to add a disk persistently. Then libvirt is storing that information in the domain XML. And if you say I don't want to have it persistent, then the disk is only there until you shut down the virtual machine, and it doesn't make it into the on disk domain description XML file. It's just in memory. So yeah, it makes sense that it might be possible to do the same with pass-throughs. Yes, I just never have seen it.
Right, and then I guess the issue you still run into with VMs is that if you want to reboot the host machine to, you know, rescan a card or whatever, then that you have to kill all the other VMs. So that I'm not sure.
That's a problem.
Does LabGrid actually have support for that sort of thing? Like, it seems like that's just going to cause all sorts of problems, because what happens if one of those VMs is locked by somebody else? I guess you just have to wait.
Yeah,
locked.
that's something we are looking into adding, actually. So we have this problem with a couple of different resources. So we have power distributions that kind of is shared, right? So if you switch one power device on, it's a couple of boards being turned on. So you want to turn it on with the first one in use and switch it off with the last one being switched off, right? So that's a similar thing with VMs.
Well, that shouldn't be true. That's the reference counting, right?
Yeah, exactly, right. So it shouldn't be too bad. But yeah, so that's the same thing, and the same thing is also for a switch. So if you have a switch with 20 ports and you have a couple of setups using the same switch as a shared resource, you also want to make sure that it runs as long as the last place is in use. And the same is like with a host machine. You want to have this being able to be powered off once all VMs are shut down, not before.
Right, but the question is more like, okay, if you need to force a warm reboot for some reason of the host machine, you know, how do you do that?
Well, you can, what you can do is you can kind of kick somebody from the setup. So if your LabGrid acquires something, somebody else can kick you. So it's possible, but not the nice way of attack, right? But every now and then somebody forgets about releasing hardware and everything. So yeah, it's people. It's more usually a people problem.
Well, I mean, but more does LabVIEW have or LabGrid have a way to prevent somebody from rebooting, you know, a host machine if there's two different sessions on that machine?
Okay.
Or
not yet.
Not yet. Okay.
Well, I would say there is a level of protection. So if we would if you just offer the VMs via LabGrid, then the host machine is basically not an object, not a resource of any kind for the user. The user just can acquire and operate VMs. So, and that's a protection. You basically don't offer access to the host in terms of LabGrid.
But then that limits what you can do, because if you do need to reboot the host, then your host, you can't do whatever operation that needs the host to be rebooted.
Right. In my mind, this then would be a kind of a feature of this. They also call it a driver module, I think, which is, I guess, running on the exporter node. That would then have to accept a reboot command. And the exporter then, which manages all the VMs on one host, would then have to see, well, can I carry out that reboot now, or is it not possible because other machines are in use? At least that would be what comes up in my mind currently.
Yeah, and then I guess another concern is, shall we say, collateral damage. So, you know, if you're doing driver development and you screw something up and the whole host machine hangs, and there's other people use it.
Yeah.
I guess maybe the trick is you have to have one computer, one everything per host machine, just manage the whole machine. Otherwise, because that eliminates all these problems. If you only have one person using the host machine, one VM on the host machine, then you can just reboot it or crash it or whatever. It's not a problem.
Yeah, but crashing a host machine from a VM, I mean, anything can happen, of course.
I mean,
Murphy's
that's
law,
difficult,
but
but
it's not
I mean, it's
that
like, yeah,
likely, I would say.
well, so crashing from a VM, it's going to be hard. I think unless you're talking about, custom PCIe devices and PCIe pass-through and stuff.
Right. Crashing the
So-
machine from a from a from a FPGA design is easy.
Yeah. And that is the concern here. So, I mean, so that's kind of what I was talking about between, booting machines into LabGrid versus using them directly, right? It's like you could
Yeah.
boot up a machine that has, in a configuration that has multiple VMs set up. It's configured in a way that LabGrid can manage it versus boot it up in a way that I'm just going to run bare metal on this thing. And LabGrid cannot manage it. And then
Yeah.
you can do that just on an as-needed basis. If you wanted to use LabGrid and a bunch of VMs, you can do that. If you want to run it bare metal without LabGrid, you can do that. That's
Yeah, but
kind
the
of
point would be, as Uli explained, the LabGrid thing itself is completely orthogonal. I mean, you can also use LabGrid to manage the host machine. Why not? So LabGrid is
Yeah.
really about just managing resources and having a concept of what is called this place, which is combining certain resources and associating it with the user.
right.
So,
Yeah, so one of the ideas we had for these hierarchical resources could be or would be if you're kind of acquiring a place that uses child resources, for example, one VM on a host, this child resource would internally kind of also use the parent resource. So it's not an exclusive use, but it's in use. So from a LabGrid perspective, somebody else couldn't acquire this one to do something with it. So it's already locked because somebody uses something that depends on it. Right? So in this way, you block somebody logging into a hypervisor while a VM is, or logging in would be done differently, but you're kind of preventing somebody to use it directly in a mode that might be a problem for a VM user, right? and if there is no VM running, you could just use the plain host and operate it as there wouldn't be any other VMs possible to run on them.
Right, yeah. So that's got me thinking, okay, what if we did use a little additional computer, in line with the main host computer? I guess that would potentially solve some of the problems. So one of the issues that I was trying to figure out is how do you prevent, if you have multiple machines that are net booting, how do you prevent them from accessing the roots of the other machines over the network, right? Because they're all, NFS doesn't really have much in terms of security. But if you had a host sitting in between, and you just run the network through that host machine, then, or that through that separate control machine, then that one could only expose the NFS mounts that are necessary for, the machine that you're controlling to boot. And, then you don't expose any other mounts. So that would potentially solve that problem there to some extent anyway, because you can kind of filter what's exposed and what isn't. And firewall things accordingly and whatnot. So then what you could potentially do is have LabGrid manage which image is being booted on the host machine, because you can switch up the NFS mounts, power cycle the machine, and then it'll boot to whichever image you want. And then instead of having like one centralized TFTP server and whatnot, you would manage that just directly. Each one of these nodes would have its own TFTP server and would forward the NFS mounts from, probably a NAS device, something like that. That kind of makes sense what I'm describing, or?
So I guess I'm out on this side, but yeah, Joachim, go ahead. Sorry.
Yeah, I mean, that's yeah, a good point. At least that if you don't want to have all users access to all other users' roots, I mean, a typical setup is also to export the root file system actually read only, and have a layered overlay file system going on. And but of course, again, you don't want to have a user access to another user's overlay.
Right.
So
Yeah. I mean,
the
I guess there's a
problem,
couple different directions you could take it in. I'm thinking it makes sense to make them read write so that people can actually install packages persistently and whatnot.
no,
But
overlay could also be persistent. I mean, you could have
right.
the overlay in RAM, of course, yeah, but you can also have the overlay in on another mount,
Right.
NFS
But
mount.
I guess again that brings up the same issue because even if the
Yeah,
overlay
yeah.
is read write, even if it's on a separate mount, you still need to be able to see that during boot. So yeah. Anyway, the idea is that LabGrid could manage those images in some way, perhaps. So you could use LabGrid to pick which image you want to boot on a given machine, and then it could do the configuration to actually boot that. Poke at the NFS setup, and then you could potentially have a couple of canned images as well. So you could have your own user image, which is just whatever you want, and you can create as many of those as you want. And then you could potentially have another image which is set up for several VMs, basically. And then you could boot that if you wanted to run, multiple VMs in a more standardized way.
Yeah. Yeah. So I guess it would be a special LabGrid driver, which basically manages the NFS server's configuration, the TFTP server, so that the TFTP server is configured in a way to hand out a certain boot image to a certain MAC address, and so LabGrid driver, which dynamically adjusts the configuration of a TFTP server and the NFS server.
Right, but I guess part of it is that if you are changing the configuration of a host that drastically, does I guess LabGrid probably doesn't currently have the capability of tracking that, right? So it's like if a host is booted to this image, then LabGrid would just handle that machine directly. Versus if it's booted to a different image, then it would treat it as several resources.
Yeah. And, yeah, I mean the LabGrid concept is there, but if you have a certain type of resource and manage that resource, you basically have to add support for it and write a driver, basically a LabGrid driver for a resource. The concept is there, and they have.
Yeah, I'm thinking more in terms of kind of a higher level thing. Like you have two different potential configurations of a given resource, right? Because you're talking about hierarchical things where you have sub resources and whatnot. So in this case, you would have, two different configurations. One of them where it's just a single resource, and another one where you have, these VMs that can potentially be managed separately. So I'm guessing there probably isn't support for something like that in LabGrid right now, because you'd basically be changing the LabGrid configuration, right? Do we have one host, or do we have one host with several VMs on it? And that would have to be changed dynamically based on which image is booted.
Yeah, good point. Yeah.
So I guess to make that work, you'd have to make probably modifications to LabGrid upstream. So
Yeah, for a lot of things we talked about
You'd have
in
to
the
make
past minutes. You have
modifications.
to,
Okay.
yeah. It's in my mind the concept, the LabGrid concept with the resource management is there, but well, they support the usual things you want to have if you have such embedded hardware, small Raspberry Pi like boards. So they have drivers for accessing a serial port, for SSH, for this SD Max thing. All they have drivers for these basics, but for anything else, you basically have to add drivers.
Right.
But even if such a driver is not there, it's a, I would say, a good tool to start with, to just, for example, basically manage access to machines and say, well,
Right.
I acquire this machine, and so the management software says who has this machine acquired, and for example, can power it on, can power it off. So I think it would be useful even if even in this state of not having drivers for all special things.
Okay. Well, I mean, probably worth spending some time playing around with that. I guess I'll take a look at that at some point. I mean, it's kind of my concern is just, I only have so many cycles to work on this stuff. I don't want to spend hours and hours and hours screwing around with test bed.
Yeah.
So the simplest thing that I can put on there, unless there's somebody else that wants to, work on it remotely or something, maybe there's a way we can set that up. I don't know. Not sure. That's why I'm like, well, the simpler the setup, the better. It's like LabGrid sounds great, but it also sounds like it could just be horribly complicated to set up and configure and manage and whatnot. It's like if we had somebody to do that full time or something, then okay, fair enough. But if it's just me, I'm like, well, the simpler the better. Well, I'll do some more reading into LabGrid and see if I can wrap my head around how it works a little better. And I can certainly send you guys questions if I have any. So.
Yeah, just do so.
All right.
We could also, if you're interested, at some point, we could also just do a quick little live demo, right? And log into one of our setups and poke around, show the config of the exporter, whatever.
Yeah,
might be interesting
possibly.
At some point. But yeah, as you like.
Yeah. All right.
Good.
Well, is there anything else people want to talk about? I guess Julian had something that maybe we were going to discuss, but I guess he timed out. So,
Oops.
well. Next time,
I don't want to bother you too much, guys. I'm new in the project. I'm currently working at CERN for the update of the switch, the White Rabbit switch v4, and
very nice.
thank you. And I was interested in to know where you were in the integration of the NIC in the switch, just to know, because I'm probably have to choose between two different NICs. So we're interested in your project, and there's also another NIC that some independent guy realized for us. So yeah, just wanted to know a little bit more.
So you guys so this is a new version of the White Rabbit switch?
Yeah.
And this is 1 gig, 10 gig, 100
this
gig?
Is 10 gig.
10 gig, okay.
Yeah.
And this is, so the actual switch portion of it, the forwarding and whatnot, this is something you guys are working on as well? Or you have that working?
Yeah, so we're For now, we're taking back some of the code. We're upgrading the hardware, but we're interested of the NIC to in order to connect the PS part of our ultra scale to the switch core.
Right. Right. Yeah. So Corundum, it does run on ultra scale devices on the Zinc devices. It sounds like you're using one of those with the
Yeah, we're
PS?
using
Yeah.
ultra scale plus.
Right. Okay.
So it does work on ultra scale plus. You said?
Right. It
Oh,
does work on Zinc devices. So it runs
okay.
on the ZC102, ZC106. You know,
Okay.
with the Zinc ARM cores as the host. So I know
Okay.
MLE is actually using it in that configuration. I think for one of their projects.
So you already have some drivers for the NIC?
Yeah.
Yes.
As
yeah,
a
okay.
NIC, it's been working for a long time, and
Okay.
yeah, the MLE guys helped get the Peta Linux support sorted out.
Okay.
Well, I guess partially Peta Linux support and also partially the platform device support. So it also runs on like the KR260 under the Ubuntu image. You know,
Okay.
all that
All
stuff
right.
works.
Yeah. So we have a production product running on this.
Okay.
Yeah. So from that standpoint, everything works. On this, you know, in terms of the switch integration, there's probably more stuff that needs to be done. But I guess from my point of view, it's more like, you know, Carlos is working on the actual switch, and then that's going to have to be integrated with the rest of the design. So without a switch, there's not much to integrate.
Yeah, I
But
understand.
I
You
guess
need
you
the hardware.
guys might have a switch. It sounds like
Not
so.
yet, actually,
Not
not
yet.
yet.
Okay.
We are still.
Well, talk to
It's
Carlos. You know.
but
Although
I'm working
Carlos is
on
targeting more like 100 gigs, so I'm sure it would
Okay.
work at 10 gig, but
But
give you some room to grow, I suppose.
I think that you gave to one of my colleagues some kind of development board. I don't know if it's you. Actually, I don't know who gave it, but I think it's people from Meta who gave him. So I don't know if you
Oh,
know
okay.
Maciek. It's Maciek
Yeah.
Lubinski.
I've been talking with those guys a little bit. So what they gave you a board, like, was this pretty recent?
Yeah, I think so. It
Okay.
was the only part available. I think so. So yeah,
I think 2 weeks ago.
Yeah. Okay.
So they sent you one, but they haven't sent me one.
Oh.
Well, great. Okay.
So
this is with the KR with the SOM on it, with the K26.
Yeah, I think so. Yeah, with the SOM.
Right. Yeah. So the plan is to get Corundum running on that. There's some gotchas on that particular board, but it's more just in terms of only having one GT quad that we got to deal with. So anyway, yeah. And I guess they also swapped out the PLL chip or something. I'm not sure what for whatever reason they haven't been keeping me in the loop on that. So
Okay.
um
But yeah, I'll try to make some tests and to keep you in the loop because for now I'm just starting, so I don't want to go too far.
right, yeah, sure. Well, I mean, we have, you know, White Rabbit channel on the Corundum Zulip, so you're welcome to ask questions about, you know, in there about whatever. So I think there was,
And
So
I'm not sure if it makes sense for anybody else from CERN, White Rabbit to join these discussions as well. So it's nice that we have one person, so that's a start.
so
Were you gonna say
where's
something?
the
Oh,
channel you told me?
the Zulip, you're not are you
I'm on
connected with
the
that?
Google groups, but
Okay. Let me post a link here.
Yeah.
It's kind of a Slack alternative.
thank you. Okay. Nice.
there's a plethora of different channels.
Yeah. I should probably make a few more of them, you know, default channels or something, because I think there's quite a few people that just join the general one and then they're like, where there's nothing here. But I don't want to put everybody in every channel because, you know, I guess it's easier to put everybody in every channel than they could leave the channels they don't want or something. Anyway, whatever. That's a different discussion, but yeah.
Yeah, maybe from a White Rabbit Corundum integration perspective, so we do have at least one funded project where we somehow have to do something like this, like integrating a 10 gigabit NIC and a 10 gigabit White Rabbit. So we are happy to join forces.
I'm happy to join too.
Yeah,
to
so
just keep us posted, I guess. So that's something we will start next year. So we are
time
running
flies,
everything
right?
on 1 gig. Yeah, it will be next week so fast. No, we are running everything on 1 gig right now, and at some point we need to switch over to 10 gig.
So you're using, I'm guessing, just the out of the box White Rabbit Mac, or
yeah, right now, yes,
1
yeah.
gig? Okay, yeah, because kind of my thought in terms of supporting White Rabbit is kind of to go the other way. Instead of using the White Rabbit code base, kind of to merge the White Rabbit functionality into Corundum. Because we already have a Mac that can run at up to 25 gig. So if we can get White Rabbit, if we can make that White Rabbit capable, basically.
Yeah, it makes sense for Corundum, but for us, I think it's a bit more complicated to go this way.
Okay. Well, actually, so that's one thing I was wondering about. So with your switch that's running at 10 gig, are you only running at 10 gig, or are you supporting 10 gig and 1 gig?
I think we are supporting both because it has to integrate in a 1 gig network. So yeah, I think it's going to do both.
Right. So I guess you must have to make some modifications to your, timing infrastructure to support running at multiple clock frequencies. Because that was one thing I was looking at some of the original White Rabbit stuff. I'm like, well, okay, you guys are kind of cheating by doing everything at the same frequency.
Yeah.
Corundum unfortunately can't do that. So
Right, but actually that's kind of the part of the concept, right? So everything is actually synchronous. It's not necessarily the same clock, but it should be in the end.
Well, sort of. I mean, you have to have multiple. You have to have a PLL in there somewhere that's generating the other.
Yeah, of course.
And because they're different, that does complicate. Okay, how do you even compare the phase of two clocks that are running at two different frequencies, right? Is that even really well defined, shall we say? So yeah, there's probably some problems in how Corundum is currently handling some of the clock stuff, which probably shouldn't be too hard to sort out. But anyway, I mean, I think the clocking is in large part related more to the board design than anything else, right? To make sure you have the right clocking network on the board that's feeding the clocks into the transceivers and whatnot. I know you guys have been looking at how to basically do White Rabbit without having tunable oscillators on the board and whatnot. So
yeah,
there's ways you can make that work. Actually, I posted a couple of ideas. I don't know if you guys had a chance to look at those. Because I know you guys were running on the ZCU 102, I think.
Yes.
And you guys had to reprogram the oscillator on there to offset it. So it's like, well, okay, if you have a board that doesn't have a programmable oscillator on there, you can't do that. So is there an alternative approach that might work? And what I was thinking of is you have the TXPI. I wonder if you could offset the QPLL and then use a TXPI to remove the offset or something along those lines. And that could be a workaround for retuning the oscillator. I'm not sure if you guys have put it.
We haven't looked at this yet. Yeah. So we are currently in kind of the first release process to our partners of the project to support actually a 7 series device. So without QPLL, Brixo, Fraxo support, so we're using just MMCMs to actually tune the frequencies, and it also works pretty good.
Not so okay. So you can tune with the MMCMs. I mean, it's not perfect, but
yeah, but it gets the lock and runs together with the White Rabbit switch. No evaluation done yet, so we definitely need to
Wait, but
need
how
to
are,
do
so you're
some.
feeding from the MMCM into the transceivers, or how are you doing the
Yeah,
talking about the link?
external loop. You need an external loop for this. So actually there is an internal path, but AMD says like, don't use it, it's bad. So we don't use it. We just go out, and there is on the boards we need to support, there is an external loop for this as well.
I see. Okay, so you're generating the clock with the MMCMs, and then you send it out and loop it back into the ref clock inputs.
Yeah.
And then
And there is
from there
more
it goes
clocks
through the
derived.
QPLL.
Yeah. And there is other clocks derived from it as well, which kind of is the idea. Yeah.
And then you're tuning the MMCM, I'm guessing, through DRP.
There is a what's the interface called? There is a phase slip interface on the MMCM, where you can every 10 cycles or 12 cycles you can skip or add PLL phase, let's say.
Oh, that's interesting. So this is through the DRP interface or through some other pins?
I think it's a custom interface.
Custom interface.
It's not DRP. Actually, so I need to.
Oh, I see.
This.
I just had the manual up a few days ago. I was looking at it like, how could we do this? Let's see, where was that one?
Anyway, that's very specific, and I guess it's interesting for playing around with it.
Oh, I see. There's a phase shift clock enable and PS.
That's the one.
Oh, all right.
That's the one. And it's, I think, 12 cycles of the clock domain you use for controlling this interface until you can issue another ink deck.
Okay. Okay, so you're basically doing a
we're doing continuous phase shifts,
feeding into that. Gotcha. Okay. Well, so I guess if it works, why not?
It's good enough to lock, at least.
Right. Yeah, I was looking at the DRP registers, but if they have that phase shift interface that's more directly exposed, and that seems like that would probably be a better idea. So why aren't you using the QPLL setup on with the, because it doesn't work with the fixed oscillator on there, or?
No, because it's 7 series. And
it's 7 series and it doesn't have
the fractional
okay,
support.
Got it. Okay. Does it have the TXPI on those guys?
Good question. I don't know out of my head.
I thought let me see here. I think I have the manual
on the hot list.
Vertex 7 or Kintex 7, or maybe
it's a Kintex GTH, I guess.
7 series transceivers, I guess it must be. Yeah, GTX/GTH. All right, so
okay,
TX Blur.
Now Quentin also timed out.
Yeah, there's a TX PPM. What?
Quentin also just left.
All right.
Yeah, I didn't want to bother you too much, but I have to go to it's late.
It's late, yeah.
All right. Well, good night.
Bye,
Keep in
guys.
touch.
Thank you. And yeah, we keep in touch. I'll try to be there in the following meetings. Thank you for the information.
Bye.
Talk to you.
Bye.
Yeah, so apparently there is a TXPI on the 7 series, TX phase interpolator PPM controller. So
okay.
That, well, I mean, I guess you might have the same problem that you had with the QPLLs, where you can only tune in certain regions, right? You can only like down tune it or something. I guess it's like, I guess with the SDM you can tune in both directions, but you can't tune across too many bits changing. So
okay.
You have to detune the oscillator for that. For the TXPI, I don't know what the restrictions are on that. but yeah, you could run into the same issue where without, you know, both the PI and the SDM, you know, fractional support in the QPLL, you could still have the same problem. So I don't know. Anyway, it might be worth playing around with. They had a I think an application note on using the TXPI for operating in synchronous mode, where you're basically turning the receiver covered clock around on a different channel. So you don't have a difference in clock frequency. But I seem to remember something like you have to tune the line rate clock a couple hundred ppm higher than normal, and then bring it back down by adjusting the TXPI. I think it's something like that.
It can also just skip cycles. Yeah.
It sounds like it's something like that. I'm not sure why it only goes in one direction. It seems like you should be able to go both, but yeah, not sure. It's worth spending some cycles playing around with and seeing what it's capable of doing. Because it's like if you look at the TXPI PPM config, that directly sets the phase interpolator in the TXPI. So it seems like you could increment that, you know, yourself instead of using their PPM controller, you know, increment it or decrement it. And it seems like that would allow you to go in either direction. But anyway, that might require some more reading. I'll have to see if I can hunt down that app note as well.
Yeah, a lot of reading and then figuring out the inconsistencies, and yeah, then you need to try it anyway.
Right. Yeah.
That's
and at
how
any
it
point,
is.
you could run into some reason why it ain't gonna work, you know.
Yeah, exactly. Cool.
All right.
So we hammered on a couple of items today.
Yeah. All right. Well, is there anything else that people want to discuss, or are we good in terms of I guess we pretty much lost everybody, so
Yep.
Oh well, that's how it works.
I don't have anything from my side. I was
All
going to
right.
say Quentin to join the meetings of the Switch to see if they are going to build some pieces, for example, the routine computation logic or something like that, to see if he can get something from us and also we
Well,
from them.
yeah, that's a good point. It sounds like that he might hop on to Zulip at some point, so we can poke him that way.
Yep.
Otherwise, we can probably try and, you know, poke some of the CERN people to, you know, talk to him that way. Yeah, I don't know what the plan is on the Switch side. So they're using an UltraScale Plus device, right? He didn't say how big. I also didn't ask how many ports they're shooting for with the Switch, but
Yeah, so the old one has 18 ports, so it shouldn't be a very small device, I guess.
right, yeah.
Yep.
Yeah, I guess the other thing that I also didn't ask about, but you can also do gigabit through just a normal I/O on those things. So it wouldn't be hard with a Zinc UltraScale device to do a bunch of 10 gig ports with the transceivers. You know, use all the transceivers for 10 gig and then toss on a few more 1 gig ports just because. I don't know if they're using any particular transceiver features. I mean, obviously, if you go in that route, you don't have the TXPIs and whatnot, but you're just doing everything with MMCMs and whatnot. But I don't think that would be an issue because the whole point is it's all one clock, right?
Yeah, well, they have external VCXO to manage their clocks. So
well, right, yeah, you tune that, and then that feeds everything. So
yeah,
both the GTs and everything else. It's more like, okay, if we don't have an external tunable oscillator, that's where things get complicated.
exactly.
But since they have that, it seems like it would probably work. Yeah, that's actually, I tried to mention that before, but that was one of the things that we were looking at doing on that board that the OCP people are putting together, is to have a couple of I guess we just put one additional SFP on there, but one that's wired to the just normal IO, so we can get that up and running as a gigabit transceiver, running White Rabbit ideally, without using the transceivers, right? Just using the IO SerDes blocks basically, or whatever the bit slice, I guess, blocks on UltraScale Plus.
Okay.
So. Because potentially, even with that K26 SOM, you could put quite a few gigabit ports on there. Because it's got a lot of pins. So now I don't know logic resource wise how well that would work,
It's just a small device.
It's pretty small. Yeah.
The ZU5.
I did a test build of Corundum on there, and it uses up a lot. Yeah, ZU5. I mean, as far as that's not the smallest. You could go a lot smaller. So.
I know.
Considering the price of those SOMs, that's actually a decent deal for that size part, I think. So,
Yeah.
Anyway, I guess if we're out of stuff to talk about, then we can go ahead and adjourn, and then talk to you guys in 1 week or 2 weeks, depending on whether you care about the Switch or not. Carlos would appreciate it if you tune in next week, I guess.
Yeah, that's true. Oh.
All right. Well, nice discussion.
Cool.
We'll talk to you guys later, and maybe we can figure out some of this lab grid stuff. We'll see.
Yeah, we'll see. So have a good week.
All right.
Bye, gents.
Sounds good.
Thank you.
Talk to you.
Thank you. Bye.
Thanks.
Bye.